Okay, so today we're going to have a look at our new topic of further integration. So further integration in Extension 2 involves a massive number of different techniques. Some you would have seen before in Advanced and Extension 1, and others will be new. As well as new techniques, integration in Extension 2 will be much harder than Extension 1, mainly because you'll be given just the bare questions with no hints, no substitutions, or no hints if any other technique is involved. It will just be a plain integral. A little mnemonic that I came across in one of the textbooks are these three things of how to integrate and differentiate different trigonometric functions. So this one here, for example, says if we differentiate sine, we get cos. This one here, if we differentiate tan, we get sec squared, sec times sec. This one, differentiate sec, you get sec x, tan x. And if you differentiate ln of tan of x plus sec of x, you get sec of x. A good go-to strategy in Extension 2 integrals is completing the square. Often if you have a quadratic denominator and you can't factorize it nicely using either the cross method or the sum and product method, we're going to complete the square. So if we completed the square on x squared plus 10x, we would get x squared plus 10x plus 25, and that would leave us with a plus 4, because 25 plus 4 is 29. So this is the integral of dx of 4 plus, we take that perfect square, x plus 5 squared. Now that's just in our tan form. So this is a half of tan inverse of x plus 5 on 2 plus c. Example 2, the integral of 1 over 16 minus 6x minus x squared. When we complete the square, we don't like, and in fact we can't have a negative coefficient of x squared. So let's take out a negative and say this is minus x squared plus 6x minus 16. We can complete the square on the middle terms now. So this is going to be dx over minus the square root of x squared plus 6 divided by 2 is 3, square that we get 9, so 6x plus 9. And then we need to subtract 25, because 9 minus 25 is minus 16. So here we've got the integral of dx over the square root of minus, and that's going to be x plus 3 squared, and then minus 25. Let's now bring through that negative. So this is the integral of dx of, we might write it as 5 squared minus x plus 3 squared. Now that's nice and easy, that's just in our sine inverse form. So this is sine inverse of x plus 3 on 5 plus c. Example 3, we're going to complete the square again. So this is the integral of dx over the square root of x squared minus 6x plus 9. But if we want 5 and we've got 9, we need to subtract 4. So this is the integral of dx over the square root of x minus 3 squared minus 4. Now this question here is a bit interesting because we haven't seen how to integrate something like this. Now if we go to page 1 of this booklet, we actually get it's the integral of, what did we have? We had minus, so it's this one here, ln of f of x of square root of f of x squared minus a squared. So that's just a common integral that you will see in Extension 2. So this is ln of the absolute value of x minus 3 plus the square root of f of x squared minus a squared, so x minus 3 squared minus 4. And that would be our answer there. Okay. Example number 4. So we're completing the square, but it's not as pretty. So this is the integral of 1 over x squared minus x, and this time it's going to be plus a quarter. But if we plus a quarter and we want to get to 1, we need to plus another 3/4. So this is the integral of dx over x minus a half squared plus 3/4. Now we want to put that in our tan form, so this is going to be the integral of dx of, we might say, root 3 on 2 squared plus x minus a half squared, and that will give us 2 on root 3 tan inverse of x minus a half on root 3 on 2, which if we simplify will be 2 on root 3 tan inverse of 2x minus 1 on root 3 plus c. Alright, thanks for listening.